Welcome, this is going to be our lecture video for May 4th. Let's go ahead and get started with this problem right here. How high up is this airplane? I strongly encourage you to pause the video now, sketch this diagram, maybe put today's date at the top of your notes, and see if you can figure it out using just right triangle trig. It's maybe a little bit harder than it looks like initially. Feels like we can just do one trig function and figure it out, but we actually have to do two here. All right, so hopefully you've got it drawn. Hopefully you've tried this problem. Here's how we're going to figure this out. So we know this angle, and we know the distance between these two dishes is 20 miles, and we know this angle here. Don't be tricked. It's not 20 miles to right here, because then actually we could just do one trig function and be done. It's 20 miles between the two. The whole bottom of this triangle is 20 miles. So we're going to set a variable here, establish a variable. We're going to say that's x, and then this length over here would be 20 minus x. So we're dividing up that 20 into an x and a 20 minus x. Together they would make 20. Now let's set up the trig functions for both of these. So from this angle 15, the height that I want to know right here would be the opposite, and this 20 minus x would be the adjacent. Same thing from here. This would be the opposite. This x would be the adjacent. So I can say opposite and adjacent, that's related by tangent. So the tangent of 15 degrees is equal to opposite, which I've designated as h, divided by adjacent, which is 20 minus x. Same thing over here, but now it's tangent of 35 equals opposite, h, over adjacent, which I've established as x. Now we've got a system of equations. All right, let me get you started on solving this. One thing is, this is tangent of 15 degrees. This is something we can plug into our calculator and turn into a decimal. Just make sure you are in degree mode. I'm in rating mode, so I'm going to switch it over to degree mode. Then I'm going to do tangent of 15 degrees. And I get 0.27, we'll say. I'm rounding up a little bit there. Equals h over 20 minus x. So how I can say this is I don't know either the opposite or the adjacent, but I know the ratio between the two of them is 0.27. For every right triangle with a 15-degree angle, the opposite is 27% as long as the adjacent. All right, we can do the same thing over here. Just plug in tangent of 35. This has a number. It is 0.70, around, equals h over x. Now this is a little bit easier system to solve. Now there's no more trig function in there. Let's go ahead and get rid of this fraction by multiplying both sides by 20 minus x. So we got 0.27 times 20 minus x equals h, and I'll multiply x to both sides of this one. We get 0.7x equals h. Now I can do substitution, bring this over here. And I'll go ahead and distribute in this 0.27. So 0.27 times 20 is 5.4 minus 0.27x equals 0.7x. And combine like terms by moving this 0.27x over to this side. 5.4 equals 0.97x. Divide. And we get approximately 5.56. So I'd round up to 5.57 equals x. But that's not, so that solves for this length right here. We still have to find the hypotenuse. I think a good spot to plug this in would be maybe right here. 0.7 times 5.57 equals h. So multiply by 0.7, and I get 3.8, well, we'll round up to 3.9 miles equals h. I'm going to multiply that by 5280 to get that this airplane here is cruising at roughly 20,575 feet, which is not unreasonable. I think airplanes can go much higher than that. I think they can go up to 30,000, at least the big ones. So pretty realistic problem here. A way we can use basic right triangle trig to calculate the heights of airplanes if all you've got are some dishes on the ground. Okay, goal for today is to develop the area of a triangle formula. This is for non-right triangles, and the law of sines to use with non-right triangles. Why are we doing this? So we don't have to convert everything into right triangles to be able to find missing angles and sides. Let me just take a quick pause here. All right, so testing your knowledge a little bit. What is the area formula for a right triangle, or a triangle where we know the base and the height? Does anybody remember this one? Hopefully a couple people. Area equals base times height. And this one would be 5 times 12, or 60 units squared. All right, easy enough. What about a non-right triangle like this where we don't know the height? What is the area of this triangle? Again, I encourage you to pause the video here and try to find this one on your own. At least sketch the diagram. Okay, so although we don't know the height of this triangle, we can still use our area formula. Area equals 1/2 base times height if we can figure out the height. Every triangle still has a height, even if it's a non-right triangle. The height for this one would be the distance, like if this was like a building off the ground that point reaches. So you just have to extend the triangle over into a right triangle, and this length here is still considered the height. Right, so you can move that point anywhere along this line up here, and that height's not going to change, and this area is not going to change. Now can we figure out how long that is? Well, to do that, we can do a little bit of trigonometry. We need to figure out this angle in here. Any ideas on how to figure out this angle? Well, these two angles together make a straight line, or a 180-degree angle, so I can do 180 minus 123. 180 minus 123 is equal to 57. So I did 180 minus 123. And now I've got an angle and a side length within a right triangle, so I can set up a little bit of trigonometry. So this is the hypotenuse. The height is the opposite. So opposite and hypotenuse, I'm going to use sine. So the sine of 57 degrees equals h over, and I know this length is 231. Multiply 231 to both sides. I can plug this whole thing into my calculator. I'll just do it as 231 times sine of 57. Make sure that calculator is still in degree mode, and we get that the height here equals 193.7 meters. Now I can use my formula, 1/2. This 150 is the base. So times 150 times the height of 193.7. So just, I've got this still on my calculator, so I multiply by 150. I divide by 2, and I get 1,014,529.97 square meters. It's a very big triangle. Okay, so we converted it into a right triangle to be able to find this. Is there a better way? Well, first off, we need to know how to label the sides and angles of a non-right triangle. When you've got the right angle, then it's, opposite, adjacent, and hypotenuse, but there's no right angle to base anything off of. So you just label it ABC. But here's the key. We use capitals for angles. And then if we look here, the side opposite gets the same letter. So opposite of capital C is lowercase c. All right, so can we develop a formula that will find the area of a triangle without us having to convert it into a right triangle every single time? Well, what we're going to do is we're going to convert our generic triangle into a right triangle and see if we can come up with a formula. So I drop down a height here, and I can say this height is equal to, this would be the opposite, and this would be the hypotenuse to angle A. So the sine of angle A equals h over b. But now I want a formula that doesn't use h. So the area of this triangle would now be 1/2 base. The base of this triangle is c, so c times the height. So let's solve this for the height. So I'm going to multiply b to both sides. Just bring the b over here. And this becomes b sine A. And then I want these to go in alphabetical order. So I get my formula. Area equals 1/2 BC sine A. All right. Now, I didn't have to do it based off of angle A. I could have done it based off of angle B or angle C. So that gives us 3 different formulas. And they're really easy to remember. These look kind of confusing, but they're actually super easy. First, just remember 1/2 base times height, and you'll be halfway there. So that's where the 1/2 comes from, and then the 2 side lengths. But if you notice, it's always 3 different letters. So it's 1/2 AB sine C, or BC sine A, or AC sine B. And these are 2 side lengths. And this is the included angle. Means that's the angle between A and B. And so you don't even really have to remember these variables. You have to just look for 2 side lengths in the included angle, and you can find the area of that triangle really quickly. So here we've got a triangle. We want to find its area. I've got 2 side lengths in the angle in between them. So here's how quickly it can be done. Area equals 10 times 12 times sine of 72. AB sine C. Technically here we've got BC sine A. Doesn't really matter. We've got 2 side lengths in the included angle. And just remember to always use sine there. Let's plug this all into our calculator. You can just do it in one line. 10 times 12 times the sine of 72. And I get 114 square centimeters. Easy as that. All right. There's another cool relationship between angles and non-right triangles. And I'm just going to give it away right here. This is called the law of sines. Go ahead and copy down these 2 lines of equivalent statements. And these are super easy to remember because you just keep the same variable. Sine of A over A equals sine of B over B equals sine of C over C. And you just pick 2 out of here that you need. You don't have to set up the entire equivalent statement. Like if I've got side length A and angle A and side length B, then I can solve for angle B. And notice these 2 are just each other flipped upside down. We can do that to any formula. But these are set up to solve for an angle. And these down here are set up to solve for a length. All right, so this will help you solve any missing piece of a triangle if you've got 3 pieces of information and at least 2 of them are opposite from one another and one is opposite from what you want. So this happens all the time where you've got 3 random pieces of information. You can use them to solve for another one, and in fact we could get the other 2 pieces of information from this triangle really easily after we've got that. So every triangle has 6 pieces of information. It's got 3 angles and 3 side lengths. Having 3 of them is generally enough to solve for the other 3, especially using law of sines. Anyway, so I'm solving for a length, so I want to put the lengths on top. And here's how I want to set this up. A over sine A equals C over sine C, because that's the information that I've got. I've got angle C and side length C. Now fill in everything that you've got. So I don't know what little a is, but A over sine of 55 equals 8 over sine of 30. These ratios should be the same. I can solve for A here by just multiplying sine of 55 to both sides. A equals, I'm just going to plug this right into my calculator, 8 divided by sine of 30 times sine of 55, and I get A is 13.1 units. And then you just do a quick visual check. Does that look like about 13 if this is 8? Yeah, that's believable. Okay, we can use law of sines to figure this one out. So you've got a person on a cliff who's looking out at a helicopter. The helicopter is looking down at this boat, and the helicopter can measure this distance here and this angle, and this person can measure this angle. If this helicopter radios this guy that information, can he figure out how far he is away from the boat? Well, we just use law of sines. You don't even have to label these. You can just say, so I'm solving for length, so let's put lengths on top. 265 over sine of 48 should equal question mark over sine of 59. You just do sine of an angle and its opposite side length, sine of an angle and its opposite side length. Those ratios in any right or any triangle, non-right or otherwise, should be the same. And now we just multiply sine of 59 to both sides. Plug this straight into our calculator. 265 divided by sine of 48. Get a number that's a little bit over 350. I multiply it by sine of 59. And I get 305.7 meters. And then just, does that look like about right? Yeah, if that's 265, this is a little bit longer. Okay, now here is a slightly, ever so slightly more difficult case because I don't have a side length and its opposite angle. But I can solve for this opposite angle really quickly because I know the interior angles of a triangle have to add up to 180. So 62 plus 70 plus mystery angle C must equal 180. Subtract away 62 and 70. And I get 180 minus 62 minus 70 equals 48. So C equals 48 degrees. And now I've got an angle on the opposite side, so I can solve for these 2 lengths. So I'll set it up as 2 different equations. I'm solving for side lengths, so I put length on top. 145 over sine of 48 should equal little a over sine of 70, or 145 over sine of 48 should equal little b over sine of 62. So 145 divided by sine of 48. I'm going to store that in my calculator as alpha a because I need to use that number again. First, I'm going to multiply it by sine of 70 and get that little a, which would be the opposite side, opposite to angle A, is 183 yards. And then I'm going to do alpha A times sine of 62. And I get that this one side length over here is 172 yards. And double check just by looking at it. Looks good. More of these on the homework. There's a help video for that. Have a good rest of your day.